In today's lesson, we're going to talk about volume in the real world and how we use this maybe on a daily basis, depending on the job that we're in, or how we might use this to figure out some things in our own lives. Okay, let's take a look at our first example. It says the area of the base of a sandbox is 9.5 feet squared. So we know the area of the base, and I'm going to mark that area of the base. And the volume, we know the volume, is 7 1/8 feet cubed. Determine the height. We're going to find the height of the sandbox. So here's our sandbox. Another question over there. Okay, here's our sandbox, and it's filled with sand. And the volume is given to us. So we already know the volume, and we know the area of the base. We're looking for the height. So first let's do our formula. Let's find our formula. I'm going to see if I can squish my work over here. Volume equals the area of the base times the height. So here's our formula, and let's plug in what we know. We know volume is 7 1/8. We know the area of the base is 9 1/2. And we don't know the height, so we're going to multiply times the height. Okay? Now, we're going to use our knowledge of expressions and solving for variables, and we're going to do the opposite. So if over here we're multiplying, we want to get rid of that. We're going to divide. So we're going to divide this side by 9.5. So I'm going to switch colors here. I'm going to divide by 9.5. If I do that on this side, remember I have to do the same thing over here, so I'm going to squish it and divide by 9.5. Okay, so if I do that on this side, these will cancel out, and I'm left with h. All right, I'm going to do some work over here to figure this out. Actually, I'm going to do some work over here on this side because I'm kind of squished for room. So I have 7 1/8. I'm going to rewrite my problem, and I'm dividing it by 9 1/2. Okay, first thing I need to do is change them to improper fractions. So 7 times 8 is 56, plus 1 is 57 eighths, divided by 18 19 halves. Remember, when we divide by a fraction, we need to actually use the reciprocal, so we're going to keep our first, multiply, and flip the second to find that reciprocal. Now I'm going to simplify before I multiply to help myself out, so I'm going to cross simplify. I see a 2 in common, so 2 divided by 2 is 1, 8 divided by 2 is 4. 19 and 57, I want to think that maybe those have something in common. Well, 19 is a prime number, so the only numbers they could have in common is 19. So I'm going to try on my calculator, and I could try it by hand, but I'm going to try my calculator. 57 divided by 19, see if it works. Oh, it does, perfect. Okay, so we're going to divide by 19, let's help ourselves out. 19 divided by 19 is 1, 57 divided by 19, our calculator told us, is 3. So we're left with 3/4. So I'm going to move back over here and plug in 3/4. So my height is 3/4. These are all in feet, so I'm going to assume it's 3/4 of a foot for the height. So no matter what it gives us, if we know the formula, we can plug in numbers to fill any of them. If we know the height and the volume, we can find the area of the base, just like we found the height. Okay, same sandbox. The sandbox was filled up with sand, but after kids played, some of the sand spilled out. Now the sand is at a height of 1/2 foot. Determine the volume of the sand. Okay, let's use the same formula. So we have volume equals area of the base times the height. Now we want to determine the volume. So we don't know volume. Area of the base is still going to be the same. It's going to be the same sandbox. So the area of the base was 9.5 feet. So we're going to do 9.5 times the new height. We're just finding the height of the sand. The box didn't shrink, just the sand. So we have 1/2 foot. Okay, now let's change to a mixed number and multiply. 9 times 2 is 18, plus 1 is 19. Halves times 1/2. That is 19/4. need to change it to a mixed number. So I'm going to take 19 and divide by 4. If you can do that in your head, great. If you can't, write it out. It's okay either way. I'm going to go ahead and write it out this time because I think I can do it in my head, but I'm not quite sure and I want to be positive. So let's see, I can get 4 whole. I'm left with 3/4. Okay, so I have volume, so I know it's going to be volume, is 4 3/4 feet. And because it's volume, it's cubed. 4 3/4 feet cubed. Okay, some real life sandbox volume problems. Okay, let's take a look at the next one. The next one is a little bit trickier because there's some multiple steps in there. Okay, a special order sandbox has been created for some children to use as an archaeological dig at the zoo. That's a big word. So they're going to go to the zoo and they're going to dig for dinosaur bones. We want to find the volume of the sandbox so they'll know how much sand and bones to put inside. Okay, here is our sandbox. It's custom build, custom order. Oh boy. Okay, well we have to find the volume of the sandbox. This is going to be a challenge. All right, I'm going to use my ruler to show you where we could split it. We kind of have to split it like we did our composite two-dimensional figures. We could split it right here and have one on the left and one on the right. Or we could split it right here and have one on the top and one on the bottom. I think I would like to, for today's purpose, split it right here. If you would like a challenge and if you want to try it the other way and see if you get the same answer, that would be awesome. And then we can bring it to class and compare what we got. I do want you to work with me on this, so please work the same way that I'm doing it, and if you want to try the other way too to see if it works the same, you can do that to bring to class tomorrow. All right, so I'm going to split it right there. So I'm chopping the whole thing off. So I kind of have two sandboxes now. I have this one, and I have this one. Two completely different ones. All right, so let's see. Let's do this one here on the left. And the first thing that we're going to need to do, I'm going to use length times width times height. So I'm going to use this formula. Because I don't have an area of a base yet, I just have my length, my width, and my height. So we're going to use that. Okay, so let's call this one 1 and call this one 2. Okay, just like we have been when we split them up before. And so let's find the volume of 1. So I'm going to do number 1 over here. Okay, volume equals length times width times height. Okay, so the length from one corner, in this corner, if I chop this off and move it out of the way, we'd see the bottom down here. All the way to here is 2 3/4 meters. So my length is 2 3/4. My width is how far is it from the front to the back. And I see over here, this is the front to the back. So it's 2 meters times the height. I need to know how tall this is. Well, I think it's the same all the way around. Yeah, I think it's the same all the way around. So I think it's going to be 1/5. Okay, that was pretty easy. We didn't have to figure any measurements on there. That's good. I like that. Okay. First thing, let's change them all to mixed numbers so they're easier to multiply. So 2 times 4 is 8. 8 plus 3 is 11. Change the 2 and put it at 2 over 1. It's a mixed number now. And we'll leave the 1/5. All right, I'm going to start by multiplying these first two digits, or first two terms, and then I will do the last one. Okay, so I'm going to cross simplify first and divide by 2. And then 11 and 1. Okay, so I have 11 halves times 1/5. Nothing in common to simplify, so I'm going to just multiply. That's 11 tenths meters cubed. All right, so that's one part of my answer. I took up some room. Let's see. I'm going to squish my second one right here. This will be the second one, the number 2. Okay, so length times width times height. Okay, so my length is across this front here. So my length is 2 1/4 times my width is 4 1/3 times my height, which is still the same, it's 1/5. All right, so 2 times 4 is 8, plus 1 is 9. We're changing them to mixed numbers first. 4 times 3 is 12, and 1 is 13. And we'll keep our 1/5. All right, again, I'm going to do the first two terms, and then I'll do the last one. I see 9 and 3 have a 3 in common, so I'm going to divide by 3. 4 and 13 don't have anything in common, so I'm going to multiply 3 times 13. I'm going to do that over here on this side, because I don't know that one on the top of off the top of my head. 3 times 3 is 9. 3 times 1 is 3. So I have 39 fourths, because 4 times 1 is 4. And I'm going to multiply times 1/5. Okay, no 1 and 4 don't have anything in common. 39 and 5 don't have anything in common. So I'm just going to go ahead and multiply, and I'm going to get 39 20ths. I can simplify that because it is an improper fraction. I'm going to divide by 20. It's almost 2, because if that was 40, it would be 2. So it's going to be 1 and 19 20ths meters cubed. Again, if you're unsure about that, you can divide it out. Okay, so I have these two numbers. I should have boxed that. These two numbers together, put them back together, and it's going to be our total volume. Okay, so I'm going to move over here and add them up together. Okay, so if I have 11 tenths plus 1 and 19 20ths. Okay, I'm going to do two things at once here. I need a common denominator. So I know I can make this to a 20, so I'm going to do that, and I'm going to change this to a mixed number, or an improper fraction, down here at the same time. So to change this to a common denominator, I'm going to multiply times 2. So I'm going to 22 20ths plus, now let's change this so it's also improper. That's 20 plus 19. We go back to our 39 20ths. Okay. And I should have changed this. That's my fault. I'm sorry. This was improper also. That would make life easier. We'll do that in just a moment and show you how that would make life easier. It didn't look the same as what I practiced. Okay, so then we're going to go ahead and add 22 and 39. So I have 39 right here. I'm just going to add a 22. Save some ink. 11, 61 20ths. If I divide that out, I know in 60 there are 3, and I'm left with 1 20th. You got the same answer. Got the same answer, so that's one method. That's one method. That's our volume of the whole thing, 3 and 1/20th meters cubed. If you choose to try it where you split it this way instead, you should get the same answer. If you don't, that's okay. Bring it to class and we'll see what we did. Okay, let me show you what I did when I first practiced this. I should have changed this because it's improper. It would be 1 and 1/10. Okay, so then I did 1 and 1/10 plus 1 and 19 20ths. Then I changed this to 20ths, and I ended up with 1 and 2 20ths, 1 and 19 20ths. So then I added my whole numbers, and I got 2. And then I added my numerators, and I got 21 20ths. This would become 1 and 1/20th, so I add that 1 and that 2, and I'd had 3 and 1/20th. Still the same. I actually think this was probably the easier way here. Two different methods, two different ways. I think this would probably be the easier way that I accidentally showed you. Okay, that's it for our examples today. Any questions? Put them in your ISN, please.